Hello everyone, welcome back to the channel. Today we'll get into fine-tuning NLP models. This tutorial is no code. We'll walk through each step you need to transform a pre-trained model into something custom built for your specific task. For example, it can be question answering, this can be summarization, or any other specialized NLP application. If you're ready, let's jump right in. First, as you can see in this slide, there's fine tuning, there's BERT, there are legal documents, and there are AI lawyer. Let's talk about why fine tuning is so powerful. Fine tuning means taking a model like BERT, already trained on a massive amount of like text, and then teaching it to perform a specific task. Because these models already know a lot about language, it is much faster for us to use it and then fine tuning rather than train from scratch. And then plus you will get a better performance than you build a smaller model or training a smaller model from scratch yourself. Now let's look at this diagram and see a big picture how fine tuning work. Here at first we have a pre-trained LLM, which is already trained on massive amount of data, text. It can be from like various data sources, Wikipedia or through Reddit or through X, Twitter. So all of these is already pre-trained. So our job is to take up that pre-trained LLM and then use the specific documents that we want the model to perform that task. And then we use that to fine tuning. Fine tuning here is to change some parameters that make the model do the specific task that it may not train before. So we have, after the fine tuning step, we have the fine tuning LLM. That fine tuning LLM is now ready to answer the question from your user or perform any kind of task. For example, summarization, classification, required from your user. So in the diagram, you kind of can see that, there's a document that we wanted to use to fine tuning. So the question is, how do we let the model learn from that document? I would say this step, the data set pre-processing, it take about like 70% of the fine tuning task. And then another 30% is like fine tuning and then trying to find the right parameters, but 70% of your job is to make the right data set. As we always hear about garbage in, garbage out. So that's why, this step is so important. So step one, data preparation and cleaning. So it's depend on, different kind of task. However, this step is a must before you get into the fine tuning. The process is kind of similar. So you collect all your data, you may scrap it somewhere, you may have it, or you may synthesize, using another LLM. Then you clean, you may normalize, and then you want to remove duplicates, you want to fixing the typos, you want to remove all of the weird characters in there, or you want to do like masking, some kind of like um important information such as like personal information. You want to do padding, truncate, depending on how long, how short your sentence is. And then after you have all of that fixing, now is ready for the next step. The next one is data splitting. Typically, when if you're familiar with like machine learning process, you want to create three sets: training, validation, and testing. The training is for the model to learn from. The validation is to tune the hyperparameters, and then you can see it's like underfitting or overfitting. And then the test is to give you like a unbiased final measurement. So test is something that like, you know, the data that the model unseen and now we kind of see how generalized it is. So three different chunks: train, val, and test. Don't skip any of them. So you need to confirm that your model is like, can perform the real world data once you're done. So that's why you really need the test set there. Then after you have a train, the val, and the test, let's discuss the tokenization and chunking. So tokenizations, it turn your text into different tokens. Can thing is like a list of different integer. So each word will be mapping with like into different integer. It's depend on like the vocabulary of each model. That from there your model can finally understand your text. And for let's say you have like a small text, then you can just go and tokenize as it is. However, when you have a long text, you may need to chunk them into like different chunk. For example, like BERT, it can only, the max token is like 512 tokens for BERT. So if you do chunking, you need to have some kind of like overlapping as well. So you don't want to like lose the information there. And it's depend on like how complicated your document is. Is it only include text? Is it text with table, text with images, text with video? So it's like a various, technique for you to do chunking. But the chunking here, the purpose to chunk here is to split your document into like different part. Then from that different part, we can, fine tuning it efficiently. Okay, if you finish the data pre-processing, let's take a pause there and celebrate because that is pretty much like 70% of the job already done. Now this is the 30% left. The next step is the model selection. This is really depends on your task. For example, if you are doing some Q&A, something like BERT, RoBERTa works pretty well. For summarization, I'm seeing people often use T5. I did have T5, BERT, and then Flan T5 as well. And then these three works pretty well. If you have a very, very long document, you may consider using long former or Flan T5, which is can handle longer context here. So after you get your model select, now let's get into the fun part, fine tuning or the training phase. If you're familiar with, training, how to find the local minimum or global minimum in machine learning or deep learning, this is a very similar process. So let's say you have a library like Hugging Face Transformer, you'll load a pre-trained model, set up your training arguments, and we'll get into those later. And then you start the training loop. The model will see your training data and then update the weights using back propagation. So it's a training loop. It's getting the weight and then it's learning. And then you will track the validation metrics after each epoch. So it's like a straightforward process if you're familiar with like how back propagation work. If not, then setting up some valuation metrics or even human in the loop, let's look at the summarization or looking at the Q&A and then evaluate if it's really correct or not. Here is the training arguments that we just talked about. These are the parameters for us to tune. Again, it depends on different kind of task that you can have different parameter to tune. For example, if you are doing summarization, you may want to tune on top K, top P as well. However, these are like a generalized parameters that I am seeing it's appear everywhere in any kind of task. It is a learning rate, it's a number of epochs. It's usually like vary from like 3 to 5, depending on kind of GPU you have, batch size, gradient step, and then weight decay. So again, depending on what kind of task you would like to use. However, these are, the generalized parameters, and as I'm seeing, is appear almost everywhere in any task. Next, we have evaluation and metrics. The exact metrics really again depend on your task. For example, question answer is usually exact match and F1 score. For summarization, metrics like ROV, Blue, and burst score are common. Classification tasks, for example, you can use precision, recall, and F1. So I think it's always good to have a human in the loop. Human can come in review. For example, if you are training or fine tuning on tasks like medical techs, you may want to have some doctors come in or those who have a domain knowledge to confirm that this is the right answer. Or if you train on some legal document, you may want to have someone who have legal domain knowledge or some lawyer to come in and confirm with you that this is correct. Let's say you finish all of those tasks and then final checkup to doing some post processing by using human in the loop for tasks like question and answer. Ask yourself some questions like, does the answer hallucinate? Is there any information that you don't want it to be there? Does the model answer fully or just try to answer partially? In the summarization, you know, does it write on point or it try to hallucinate around? So sometimes you can fix those issues by using, adjusting your post processing like top P, top K to try to fix those issues. And that is the fine tuning. So again, 30% is fine tuning and the 70% is for data pre-processing. It can be challenging, but don't be scared because of all of these steps. I hope this tutorial helpful before we dive into the code. And hopefully this tutorial will give you like a big picture, a clear idea what we are about to do in fine tuning. If you have any questions, suggestions, leave it in the comments. I would love to hear from you. I would love to see the feedback and looking forward for the next tutorial when we actually do the coding for fine tuning.